Okay, so for our last problem, we have here the area word problem for rhombus, kite, trapezoid, and irregular polygon. So we have here another four figures, okay, four figures rolled in one. So we want to solve for the area of these four different figures. So we have here a kite, rhombus, a trapezoid, and of course the irregular polygon that we formed there, an irregular enneagon. So Remy wants to build a futuristic laboratory from the inside of her house using a regular shaped enneagon labeled as SNCERLYO. The laboratory is divided into three parts: the kite, the rhombus, and the trapezoid rooms. Okay, so we're given here. The given here is that the perimeter of kite INOS is equal to 96 meters. So how do we solve for the value of x given that INOS, the perimeter of INOS is 96 meters? Now we're given here additional information about IN. IN measures x plus 5 meters. Okay, and then we have SO. So SO measures x plus 7 meters. Now, one common property of a kite is that their adjacent sides are equal. So that means IN and NO, they have x plus 5 meters as their measurement for their sides. And for SO and SI, the measurement of their sides is x plus 7. So we can simply multiply this by 2. Okay, so times 2. And then we have to equate that to 96 meters because that's the perimeter. So the formula is going to be simply 2 times x plus 5 plus 2 times x plus 7 is equal to 96 meters. So why 2? Again, because the adjacent sides of a kite, the kite figure that we have here, are equal or congruent. So 2 times x, that's going to be 2x. 2 times 5, that's going to be 10, plus 2x plus 14 is equal to 96 meters. And then 2x plus 2x, that's going to be 4x is equal to 96. Then we have to transpose 10 and 14 to the other side, so that's going to be plus 24. We've transferred that to the other side, it's going to be minus 24. So 96 minus 24, we have 72. So 4x is equal to 72. Okay, and if we divide this by 4, okay, 72 divided by 4 is 18. So the value of our x is 18. Okay, there you go. So we have now the value of our x. Now we can solve for the measurement of segment IN and segment SO. So segment IM is simply going to be, so the value of our x is 18, so that's going to be simply 18 plus 5, so that's going to be 23 meters. And for our segment SO, that's going to be 18 plus 7, it's going to be 25 meters. Now we need to find the area, okay? Now we need to find the area for our given rhombus. Okay, so to solve for the area of the kite, we're given here some clues. So the measurements of the, to get the measurement of the diagonals IO, okay, IO and SN, because we need IO and SN to solve for the area of the kite. So the clue here is that their measurement is twice the sides of IN and SN respectively. So we already solved for those two sides. So IN, okay, IN is equal to 23 and SO is equal to 25. So stated here on our given, it's twice, so we have to multiply them by 2 to get the diagonals. Okay, so times 2, and then times 2, so 23 times 2, so that's 46 meters. And 25 times 2, that's 50 meters. So that means the diagonal the diagonal IO is equal to 46 meters, and the diagonal SN is equal to 50 meters. And then we can solve for the area of the kite. So the area of the kite is equal to the product of the two diagonals divided by 2. And we have here the measurement of the two diagonals, so that's 46 times 50 divided by 2. So what's 46 times 50? So that's simply 2,300. 2,300 divided by 2, so that's going to be 1,150 meters squared. So that's a very big entrance hall for the kite shaped figure that we have here. So the area of the kite is 1,150 meters squared. Now to solve for the area of the rhombus. Now the area of the rhombus is given by the base, so the base is 17x minus 14, and again the value of our x is equal to, okay, the value of our x is equal to, we've already solved that, 18. So we just simply substitute 18 here. So that's going to be 17 times 18 minus 14, okay. So 17 times 18, so that's 306, okay, 306 minus 14. And the value of our base is going to be 292. Okay. And now we want to solve for the value of our height. The value of our height is x plus 6. Again, our x is just simply 18. So 18 plus 6 is simply 24. Now that we have the value of our height and the value of our base, we can solve for the area of the rhombus. Okay, so that's going to be 292 times 24. Okay, so what's 292 times 24? That's 7,008. Okay, so the area of the rhombus of the main experimental room for the laboratory that's going to be built there is 7,008 meters squared. And then lastly, we need to solve for the area of the trapezoid of the storage room that we have here. So we have here some measurements. Okay, so let's just erase some parts here. So it's important that we just leave 7,008 meters square there. Okay, so to solve for the area of a trapezoid, we're given the formula b sub 1 plus b sub 2, okay, all over 2 times h. Okay. Okay, so we already know that the value of our x here, the value of x is equal to 18. Okay, so we have here the height. Okay, so the height of the trapezoid is equal to 18. And b sub 1, so b sub 1 is actually line segment CL, and it's parallel to line segment OY, which is 17x minus 14. And we already solved for that value, so that's 17 times 18 minus 14, so that's simply 292. So base b sub 1 is going to be 292, and then b sub 2 is 10x plus 4, and the value of our x has already been solved, so it's going to be 10 times 18 plus 4, and 10 times 18 is 180 plus 4, that's going to be 184. So 292, that's going to be plus 184 all over 2 times 18. Okay, so this will be the area of our trapezoid, or the storage room that we have here for our laboratory. So 292 plus 184, okay, 292 plus 184, so that's simply 476 divided by 2, so we get 238. And 238 times 18 to get the area. Okay, so times 18, we get 4,284. 4,284 meters squared. Okay, so that means that's the area of the trapezoid, or the storage room. Now to get the area of the entire irregular enneagon figure that we have here, SINCERLYO, so we have to simply add the measurements of the area of the kite. So the area of the kite plus the area of the rhombus plus the area of the trapezoid, we get the area of the irregular enneagon. Okay, so we get the area of the irregular enneagon that we have here. So what's the area of the kite, guys? We've already solved for that. Okay, so the area of the kite is 1,150 meters squared. Okay, 1,150. And now the area of the rhombus. So we solve for the area of the rhombus. It's actually, okay, 7,008 meters squared. Okay, so that's the one that we solved a while ago. Okay, so 7,008 meters squared. And we also have the area of the trapezoid. The area of the trapezoid that we solved a while ago is 4284 or 4,284 meters squared. So all of these figures have meters squared on them. And if we add all of these, so that's 1150 plus 7008 plus 4284, then we get 12,442 meters squared. So that means that's the area of the laboratory that will be built inside the house of our scientist here, so Remy. So Remy will need to have a space, so that's actually a big space, 12,442 meters square of space for his laboratory, for the irregular enneagon figure that we have here on our problem.